Hi, my name is Quentin Burke, and I'm a student at Quinnipiac University in Connecticut.
And my name is Cháylee Arellano, and I'm a student at Louisiana State University in Baton Rouge, Louisiana.
For 8 weeks this summer, the two of us participated in a Research Experiences for Undergraduates, or REU program, funded by the National Science Foundation at the University of South Alabama. We had the chance to study human skeletal remains from two Bronze Age tombs called an-Nar and an-Nar that were around 4,500 years old from the Emirate of Ras Al Khaimah in the United Arab Emirates. Before starting our research, we engaged in an osteology course to learn the many bones that make up the human body. In 2 weeks' time, we learned about every bone from head to toe, including how to identify small fragments of bone.
Afterwards, we were introduced to the prehistory of southeastern Arabia. Tombs an-Nar and an-Nar date to what is called the an-Nar period, which began around 2700 BCE and ended 700 years later. The an-Nar period was marked by a rapid change in how people were taking care of their dead, along with changes in settlement, pottery, and agriculture. At this time, oasis agriculture emerged, and various plants were being domesticated for human use, including the date palm. The tombs were made of both worked and unworked stone, and hundreds of people were placed within them.
The bones found within tombs an-Nar and an-Nar were highly fragmented and commingled, or mixed together, making it impossible to identify any individuals. Adding to this complication is the fact that the bones were cremated or burned to varying degrees. Still, it is incredibly important to understand how many people may have been in the tombs and how those numbers changed over time, which is where our project came in.
With this knowledge of osteology in the prehistory of the UAE, we began our research project, which focused on finding the minimum number of individuals, or MNI, in each of the two tombs. The MNI is the lowest estimated number of people laid to rest. This number would then give us a sense of how many people were placed in each tomb. We selected the mandible, or lower jawbone, to assess MNI for both an-Nar and an-Nar.
We first developed hypotheses, or educated guesses, based on information we found during our research of the site and surrounding area. We hypothesized that the MNI for each tomb would be different since tomb an-Nar had a smaller diameter of 11.5 meters compared to a 14.5 meter diameter for an-Nar. an-Nar also had fewer chambers than an-Nar, which we thought would also affect the number of people buried in the tombs.
Our next hypothesis actually predicted the opposite of our first hypothesis, that tomb an-Nar would have a lower MNI than an-Nar, as the dates in which an-Nar was used were closer to the cultural collapse of the an-Nar period, around 2000 BCE. Around that time, there were also changes in the climate, making the area much drier than before. That could have affected population size.
Our final hypothesis involved the methods we used to determine MNI. First, we selected the zonation method, in which the mandible is split into 7 different zones based on how the bone would have likely fragmented. By counting which zone appeared the most in our data, we could determine the minimum number of people buried in the tombs. Our second method to estimate MNI, the landmark method, involved selecting 14 identifiable features on the mandible, such as the mental spines, which are a site of muscle attachments found on the inside of the chin, and mandibular condyles, part of the joint that connects the lower jaw to the skull. By finding out which landmark appeared most often in our data, we could find out the minimum number of people buried in the tombs. We hypothesized that both methods would yield the same MNI within each tomb since the landmarks and zones were similar to one another.
In total, we evaluated around 1,500 mandible fragments for both landmarks and zones, which meant that in time, our data sheet grew to quite a large size. We had assumed that the mandibular condyles would have given us our highest MNI count. However, data collection revealed that the mental spines gave us our highest count for the landmark method, while for the zonation method, the highest MNI count was given by zone 7, the area of the jaw between the left incisors and left canine. This was true in both tombs. In the end, we found that the MNI counts using the landmark method produced a minimum count of 101 individuals within tomb an-Nar and 290 individuals in an-Nar. The counts for zonation predicted fewer individuals with a minimum of 86 people for an-Nar and 263 individuals within an-Nar.
This means that more people were laid to rest in an-Nar rather than an-Nar. However, this number cannot be used as an exact count of how many people were actually in the tomb. There were likely more than our count suggests. We then compared tombs an-Nar 1 and an-Nar 2 with other an-Nar period tombs in the region to see whether there was any correlation between MNI and tomb size. We found that there was no connection between the amount of people laid to rest and the size of the tomb. This would suggest that perhaps the size of the tomb held a different meaning to the people of the an-Nar period, although this meaning is still unclear. Future research on MNI may shed additional light on these questions.
And by examining these mandibular fragments, we now have a sense of how many people were buried in each tomb, and how this compared with other an-Nar tombs in the region. Finally, we would like to thank both Dr. Jamie Ullinger and Dr. Leslie Gregorica for all the help they provided to us throughout the project as our directors. We would also like to extend our thanks to the project mentors whose advice helped to guide our research, including Dr. Amelia Hubbard and Dr. Alexis Boutin.